So as I mentioned in the previous part of this lesson, the arbitrary-arity methods are powerful, but they're a little bit cumbersome to program. And so we're going to begin our discussion of how to address those problems with the tedious and error-prone nature of allOf by discussing the design of something called the FuturesCollector class. And in this part of the method, in this part of the lesson, we're first going to talk about the limitations with the arbitrary methods that motivate this, the arbitrary-arity methods that motivate the need for a wrapper. And then we're going to talk about how to design the wrapper. And then the next part of the lesson will show the implementation of that wrapper. So first, let's motivate why we need to wrap this stuff in the first place. So the issue here is that the arbitrary-arity methods, kind of a mouthful, are hard to program directly. It's like the Gordian knot of programming. It's complicated. Why is this? Well, there's a couple reasons. First, they're past an array of completable futures. And oddly enough, the typical thing you've got at the point when you want to do something with the completable futures, they're usually in a list form. And this darn thing wants them to be in an array form. And that's just cumbersome and more effort than you would like to have to program that. It's really ugly, as you'll see here in a second. I don't know why on earth they don't just have a variant of allOf or anyOf that takes a list. You'd think that would be a very simple thing to do, but they don't. So we have to adapt somehow. And the second thing that makes them complicated is they're not strongly typed. And what the heck does that mean? They return a completable future to void or object. So if you take a look here, you can see that allOf returns a completable future to void. anyOf returns a completable future to object. So they've lost whatever type information was available when we called the methods. Now, that is by design. There's a reason for that, because the way these things work, and this is actually sort of a virtue at some level, you can pass in a whole bunch of completable futures that are not related to each other at all. But that then raises the question, what the heck do you do when you get a result back? How do you know the type of what you're dealing with? And that can be tricky. So, because of these complexities, it's often useful to create a wrapper, a candy bar wrapper, that encapsulates programmers from the accidental complexities of allOf and anyOf, whether they're intended or not, just to make them easier to deal with. So to do this, we're going to define a class we call FuturesCollector. That's a wrapper that returns one completable future, in this particular case, to a stream of big fraction objects that are being reduced and multiplied asynchronously. And actually, I take it back. It returns a completable future to a list of big fraction objects. There's another variant that returns a stream of big fraction objects, and we'll take a look at that later. So here's how we use it in the context of our case study in the EX8 project, in my Java 8 folder, in my live lessons GitHub repository. You can see here that we have this call to a factory method called toFuture that returns a collector that will collect the completable futures in the stream and then return a completable future, the one and only completable future, that will be triggered when everything else finishes. So let's talk about the design of the FuturesCollector class, and then we'll talk about the implementation in the next part of the lesson. So we wrap allOf so it works with the Java Streams framework. We don't have to do this. There's other ways of doing this. We could make a standalone method, but I like doing it as a collector because it's very clever and clean and works nicely when we integrate it with Java Streams. And as you'll see, I'm a big fan of using completable futures with Java Streams, Java sequential streams, to give better structure to the program. So here's what things look like. We have this FuturesCollector class, and it converts a stream of completable futures into a single completable future that's triggered when all the futures in the stream complete. Remember, future means completable future in this context. The FuturesCollector class, in turn, implements the collector interface. And if you recall from our previous discussions when we were talking about streams and parallel streams, you can implement custom collectors that have 5 factory methods that make things like the supplier and the accumulator and so on. And that's exactly what FuturesCollector does. A collector, just to recap what you probably already know, is used to accumulate the elements in an input stream into a so-called mutable result container. And we get to define what we want all those things to be. So the FuturesCollector, as we'll see in the next part of the lesson, provides a very powerful wrapper for some otherwise complicated code. And you'll see when we look at the implementation that this is ugliness you don't want to have to keep rewriting yourself over and over again every time you need to use this type of a feature. So that's the end of the quick overview of designing the FuturesCollector class. Now we're going to talk about the implementation of the FuturesCollector class.